Hi everyone and welcome to this new Substance Designer 5 tutorial. Today we are going to make a tutorial about something that I tried just to play once again with the pixel processor in Substance Designer 5, and it's a fine edge detect, which is basically something that gives you that. I will put in 1 like that, it will be clearer. So I guess you have understood what it does. It's basically highlighting all the edges of the picture. Why did I do that? Just for playing first, as I told you, and second, because if you look at the edge detect inside the project, it's not exactly the same technology. So if I plug this inside like that, it won't give something really reliable. You see, it doesn't really handle that properly. So that's why I did it. So as you see here, it's way better, and as you will see, it's not that complicated. If we look here, well, it's a bit complicated, but as you will see, not that much. So first, what we are going to do is a bit of theory. So we're going to start from scratch. It will be easier. So fine edge detect is here. I will create a new graph. Like that. Actually, graph. I don't need outputs, as we just want to see that. And we are going to call it fine edge detect. Fine edge detect tutor. Like that. Empty. Okay. So first, what I'm going to do is to take my picture. This is a wonderful Lego scene made by my son, so he can be proud of himself. Um, and then what we need is a pixel processor. I'm going to plug it here like that, and let's go inside. So you don't need this. What you need is first a get float 2 in order to grab the position of each pixel. So you go here, you have the built-in expose variable that give you each position of each pixel. And what we're going to do now, actually the theory to detect the edge is this one. Let me go back here. What we do actually, for each pixel, what we're going to do is to look at the top pixel, the bottom pixel, the left pixel, and the right pixel. And in order to see if there is an edge, actually, what you do is you take the value, and the more different is the value, and the merchants, it means that it's an edge basically, because if you look here, for example, you see that pixels are really similar, so there is no edge, but here you see that between this pixel and this pixel, it's pretty different. So that's what we're going to do. So what we're going to do is to do a subtraction of this pixel minus this one, then this pixel minus this one. We're going to add them and do some formulas in order to obtain a result that we want. And as I say, the higher the result, the brighter the value will be of the pixel, so it will be highlighted. So I hope it's clear. If not, it will be in a few seconds. So what you want to do first is to say, okay, here I'm going to use swizzle value, swizzle float 1, and we do Control D to make another one, because what we want to do is to separate x and y. I'm going to do this way. And why do we do that? Because, as I say, we want to take the value on top and below, top, bottom, and left, right. So we have to make something like that. So basically, let me check if I'm just okay. Yeah, I'm looking at what I'm doing. Yeah. Okay, so yes, here, as you will see, we will do the one which is on top. top, bottom, and left, right, if I'm not wrong. Yes. So that's what we're going to do. Let's go here, let's go here. So in order to do that, what you need to do is to go 1 pixel up. But the thing is, you don't know the size of the image. So first what you need to do is to do another get float. I think it's get float directly, let's see. No, it's not, so it's get float 2. Get float 2 to get the size of the image, which is this. So it will give you, for example, here it's 124, so it will, the value is 124. So what we want to do is to get 1 pixel, and as you may know, in the function actually the coordinates start from 0 to 1. So 1 pixel in the coordinates is 1 divided by this value. So you do float like that. You say 1, which is the full length in the function, divided by the size. And here we're going to use a swizzle float 1 to make it work, because we are going to make it work just for square image, so to make it easier. So now we have these 3 values, which is the position X of the pixel we are processing, the position Y, and this is the offset of 1 pixel. So now what we're going to do is some first we're going to say top bottom. So top, it's X is like that, Y is top to bottom. So let's say let's see how I did that, because I think I did minus. Just want to make sure, because I did. Yeah, so first I add and I subtract, I add and I subtract, and then I rebuilt the value. Okay, let's go. So I will add, I will need 2 of these, Ctrl D, one here, perfect, and subtraction. So what I will do is I will plug X here and X here, like that, and I will say X plus the offset and X minus the offset, and here I will do the contrary. I will do, I will duplicate this first, remove that. So if I'm not wrong, I do Y plus the offset and Y minus the offset. So now we have all the value to get the coordinates. So now what we're going to do is to do some vector float in order to build the new value. So vector float 2, let me check, because once again I just want to make sure, because sometimes when you do it after, when in my case you didn't comment anything, which is not good. Yeah, so here, as you see, that's the good part. Perfect. And we have 4 frames. So here we are going to do the 4 frames, edit. So what we're going to do, so we need it, this one will be top bottom, so we're going to add a frame just to okay, and we're going to call it top minus bottom, and this one like that. We're going to oops, frame, and we're going to call it right minus left. Okay, so top versus bottom means that X is not concerned by that, so you put X and X here because it's the y-axis which is important. So it will be top, so it's minus, and then y is plus here. So here this one is the top one, this one is the bottom one, and here right now left minus right. So what we're going to do here, y is not affected, and we say right minus left, sorry, so we put the plus value here and the minus value here. So here actually, if I continue like this, it won't work directly because actually you have to take what you want is the difference, but actually the absolute value of the difference, meaning it has to be always a positive number, and we have to keep the high value. So what we're going to do, if you look here, is to say, okay, if I'm not wrong, it will be later. What we're going to do is to do the subtraction, but we're going to take the absolute value. So what we're going to do right now is to say, we have this value, we have this value, we are going to grab the color, make the difference between, and take the absolute value, so we are sure we have the good value in fact. So let's do it. So right now, as we said, we have this and that. So what we're going to do is to use a sampler to so for each pixel, top and bottom, we are going to catch the pixel value around the actual pixel. So we go here, and as we want the difference, we do subtraction. Yep, subtraction. I don't know if there is not a misspelling here. So as I say, we just want positive value, and we want the absolute value of this. So absolute, Control D, and right now we are going to add these two numbers, if I'm not wrong. Let's see that. Let's double check. Yeah, we are going to add this and then multiply. Okay. So let's add. So let's see what it gives. So if I do that, set as output node. So if I do this and this, you see, you already get the value. So it already works. As you see, there is some artifacts on the border. This is normal, and you cannot really avoid. Actually, let me check one. Yeah, you see there is artifacts. You cannot really avoid it. It's because as it's looking above the value, on top of this you will have that, but it's not necessarily made to tile. So it has to be tested. It depends on your input, I guess. So let's go here. So basically, if we summarize, Here we separate the x and y value. Here we calculate the offset, the 1 pixel offset depending on the size of the texture. Here we say we calculate the coordinates of the pixel on top, if I'm not wrong, then on the bottom, and then the same thing on the right and on the left. I can't remember by heart the order, but it works. Then here we do the subtraction, top minus bottom, so we recalculate the exact coordinate of the pixel around. We sample it to get the grayscale values, and then we do the subtraction and we get the absolute value of the subtraction. Same thing here. Then we add them together, so we got a value, and what we're going to do right now is to do a multiplication. And what we want to do is to get some control on this multiplication, so we can strengthen the value here a bit. So what we're going to do is to do a get float that points on nothing so far. So if I do that here, you will have nothing. So let's go outside the pixel processor, double click here, and let's create a variable. So we're going to call it edges strength like that. And let's go back into the pixel processor, edit, go here, you see it's written, there is a problem, and let's take that, and now it works. Let's go back here, let's define the default value to 2, and let's set the maximum to 10. And now if you go here, you see that you can really reinforce that. I added another thing, which is something to remove a bit all the noise that you could have here. So in order to do that, you go here, you do edit, and what you do, let me check that, is to add an if a condition, which is let's take the value of that, and we say if the value of that is lower, so let's say lower, for example, you say if the value is lower to, let's use the float right now just to test. We're going to replace by get float to then, so if the value is lower, then put pure black. So oops, sorry, float. So then output pure black, else, well, output that. So let's see how it goes. Actually, we are going to put this exactly. Okay, so let's set this output. So here it doesn't change anything because of course this is 0, but if you go here, as you see, it starts to remove some dark stuff. So just by playing with the two settings, it will help a lot. So what we are going to do is add a get float again that we plug here, so it won't change anything right now because it considers that it's 0. And now what we're going to do, go back here, create a new parameter. This one we're going to call it black threshold. This way, label space, oops, like that. We go back into the pixel processor. Here we go there, black threshold, and here it's way too strong because it's by default to 1. So you go here, black threshold, you put the maximum to the default value to 0, and now playing, let me check, edgeware, yeah, default value is this one, and now if you play something like that, you get what you want. So basically right now you can define the strength of the threshold, and if you want to clean a bit you can as well, so you can play with the result and get anything you want. So that's it for this tutorial, so I hope you really like it. If it's the case, don't hesitate to reshare it with friends. If you have any question, feedback, don't hesitate to put them in the comments. Once again, thanks for watching, and see you in the next tutorial.